right, our final topic in our graph theory unit is the concept of a tree, okay? A tree is a graph in which any two vertices are connected by exactly one path, okay? So it means there's only one way to get there. And if you think of like branches on a tree, if you literally go out to like the tip of any, little tiny twig on a tree, there is only one way you can trace that twig back to the trunk of the tree. You have to go back to the next biggest branch and the next biggest branch and the next biggest branch. And you're not going to end up making a circuit that comes back to the end. You're going to have exactly one path that goes there. There's not going to be multiple ways to get from one spot, that end of that twig, back to the base or the trunk of that tree. Okay, so it's the same idea here. So which of the following graphs are trees? Well, in this first graph here, clearly there is more than one path connecting vertices. For example, this vertex right here, I can get to the one on its right by going just immediately to the right, or I could choose to go all the way around that way. So there are two ways to get there. That graph is not going to be a tree. So I'm going to go through here real quick, and I'm going to just cross it off. Okay, it's got a circuit, not going to work. All right, this next one, if you pick any vertex, there's only one way to get to any other vertex, no matter what it is. Part of the way you can see that is because there's no circuit. There's no way that you can make a complete circle or circuit or cycle around. Okay, everywhere you go, there's only one way to get there to any place else you're going to go. So this guy is definitely a tree. Okay. The next one you'll notice here, we've got a circuit again. So there's more than one way to get to those vertices. You could go around clockwise, you could go around counterclockwise. We can't have more than one way, so that one is not going to count. For the next one, again, we've got right in here, we've got a circuit again happening. I can go around and around and around and around and around and around again and again. That is not allowed in a tree. Okay, so we're going to throw that one out as the possibility of being a tree. And then this last graph kind of looks like the last one, actually, the one we just talked about, except if you pick any vertex and you start following it, you'll notice there aren't any circuits. There's no way that I get back to where I started. I only have one way to go in and out and in and out. And so that graph as well is a tree. All right. So a few properties of trees, things that are always true, all right? And we probably have figured this first one out just by looking at those examples. A tree will have no circuits, okay? There are no cycles that go around that you can, go around and around and around and around. That's a no-no. That's not a tree. Trees have to be connected graphs. If you have a graph that's not connected, like this and this and this and this and this, that's not a tree because there's not a way to get to for example, vertex A, and then end up over here at vertex C. You can't get there. There's not a path. Okay, so trees must be connected. Every edge in a tree is a bridge. And so if you remember what a bridge means if I take any edge out, my graph is disconnected. So let's say I go ahead and connect up those two vertices that I hadn't connected originally. If I remove any of those edges, my graph is broken into two pieces. So any edge is a bridge. And then the other part is that if there are n vertices, so like 5 vertices in this graph, notice there are 4 edges. And so there's always one less edge than there are vertices. If you throw in a 5th edge, at some point, at some place, in some instance, you have to create a circuit, okay? And that's what we're not going to do. All right, so one other vocab term for you here. So a spanning tree for a graph is a tree that results from the removal of as many edges as possible from the original graph without making the graph disconnected, okay? So a spanning tree means I have a graph, it's not a tree, and I'm going to take out as many edges as I can to get to the point where I do have a tree. All right, so if this is the original graph here that we're looking at, okay, we're going to start removing edges to the point where what I have left is a tree. Now again, lots and lots and lots of examples. Now keep in mind, we don't want any circuits. The graph has to be connected, okay? Every edge is going to end up being a bridge. And number 4 up there, property of trees, a tree with n vertices has exactly n minus 1 edges. So when I get done here, I have 5 vertices. I better have 4 edges in my tree. Okay, now be careful. What most people will do when I teach this unit is they'll say, oh, there's my tree. Well, there's 2 things wrong with that. Number 1, that's a circuit. Number 2, we've got a vertex there in the middle that's not connected to anything. So one of the things you could do using the original graph is you could certainly leave those 3 edges intact. Okay, just remove this one actually here that this arrow is pointing at. Remove this edge, get rid of it, and then you need to somehow connect in that middle vertex. So you can actually use any one of those 4 edges going from any of the corners of that square, if you will, to that vertex in the middle. That is a potential spanning tree. Again, there are many others. One such tree, if you just want to kind of look at another option, would be this one right there. You could remove all the edges on the outside, just remove that circuit, if you will, that goes around the outside and makes the square. So again, lots of options. Okay. All right, in the second example, please notice that you cannot remove this edge right there, because if you do, you make a disconnected graph. So that edge has to stay put. Then we have to make sure that our other vertices are still connected to our graph. And there are 1, 2, 3, 4, 5, 6 vertices here. And so we should have 5 edges total, 1 less than the number of vertices. Here's edge number 1. You could go with edge 2, edge 3, edge 4, edge 5. Again, one possible tree. Okay, you could also do something like this. That would be a spanning tree as well. Again, please notice I'm not adding in edges, okay? We're not putting in edges like here. That wasn't an edge to begin with. The point is I'm trying to take out edges that already exist and end up with a spanning tree. All right, so in this last one, again, we're going to remove whatever edges we can. So I'm going to kind of look at, for example, this triangle right here. I don't want a triangle because that's a circuit. And so I'm going to remove one of those 3 edges there. I'll just remove that one, for example, so you can kind of see where I'm at and why I maybe chose to remove that one. I don't want that circuit. So that's one possible option. Then I need to be sure I'm connecting in these other 3 vertices, again, using edges that already exist. All right, so if I start from this lower left vertex, for example, there is an edge that goes, this one right here, okay? I can use that edge and put that in my tree. Okay, so now I've got another one connected. I need to somehow involve this vertex right there. I need to get that in. So I can, I could, for example, go down that. I could use that edge and I could say that's the one I'm going to keep, and that's fine. So I can keep that one. And then I have to throw in this last vertex right here. Okay, and as long as I don't form a circuit, I'm okay. So when you look at it, I actually could include this one. That would work. It wouldn't give me a circuit. I could include that next edge. That wouldn't give me a circuit. I could also include that last one there. Any of those edges coming out of that vertex would be fine. I just have to pick one, okay? And again, it doesn't matter which one you pick. That is strictly up to you. So there is one such spanning tree. Again, there are many others. So the point is only to keep edges so that you are connected, but everything only leads to one vertex, no circuits, or you can think of it as removing edges. Excuse me, either way is fine.